Alright, we're going to solve this problem. And this problem is really 3 series combinations of elements. But in those series of combinations, you have parallel combinations. These 2 are in parallel, these 3 are in parallel with each other. So what I'm going to do here is I'm going to redraw the circuit, but I'm going to use boxes instead of these elements for resistors, capacitors, and inductors. And I'll label them R1, XC, V2, R3, R2, X of L1, X of L2. And then the impedances will be Z sub A, so forth, instead of Z sub 1. So to show you what I'm talking about, we're going to redraw the circuit. And R1, let's say up here, Z sub A is equal to X of C in parallel with X of L1. Okay, so that means we have Z sub A here. And then here, we have R2 in parallel with R3. But there's also a parallel with this. But we could do any one of these 2 first if we want to, since they're in the same branch. And since these 2 values are the same, we know that the product over sum of these 2 is going to be 3,400 ohms, half of that value. So let's say Z sub B, that's equal to R2 in parallel with R3. So then we have Z sub B right here in parallel with X of L2. So let's just do this let's just do this. Well, actually, we'll just do this. Z sub B, Z sub C, which is, that's going to be X of L2 in parallel with R2 in parallel with R3. Now, if we do this math, we're going to take the product of these 2, which this is really R2 times R3 divided by R2 plus R3. If we find a common denominator here, we multiply both sides by R2 plus R3. And then we get R2 X of L2, R3 X of L2, plus X of R2 X of L2 plus R2 X of L2. And I'm not going to go through all that math right here. I'm just going to show that this is Z sub E, and it's in parallel with X of L2. Better if I just do the algebra and show you as I'm doing it. And make sure we have our ground, so we have a completed circuit. Notice these 2 are in parallel, so we'll say that that's what Z sub C is, this right here. Okay, so our total impedance is R1 plus Z sub A plus Z sub C, right? So we'd have this. This is Z sub C. R1 plus Z sub A plus Z sub C. So this is the total circuit. If we find this total impedance right here, we can find the total current, because I is equal to E divided by whatever our total impedance is. And that current flowing through this whole element, that's going to give us the voltage drop across R2, which is V2, and the current flowing through X of L2, which is IL. Once we find Z sub T, that gives us the first solution to the 3 problems that we were asked to find. Okay, so now we're going to do this problem. Now we're going to do the problem. Damn. Now we're going to work out this problem with the math. We did the algebra, now we're going to work out the math. So let's redraw the last circuit that I drew, which is a voltage source. And we have R1, Z1, and ZC. R1, Z1, and ZC. And the problem wants us to find the total impedance, the voltage across B2, which is a voltage across R2, and IL, which is the current flowing through the second inductor. Let's put our ground here so we can complete the circuit. So the total impedance is going to be these combined. We can go ahead and write these values down right here. So R1 is labeled as 2,000 ohms, 2K ohms. And then we have X, let's do all the R's first. R2 and R3 are both the same. 6.8K ohms. That's same as R3. Now the X of C, that's going to be 4 kilo ohms, and X of L1 and it's probably better to write this as a negative J of 4K ohm because I have it in rectangular form here. And if I write it in polar form, it makes it a little bit better because we don't have that negative sign. It would be 4K ohms at an angle of negative 90 degrees. But just to keep it in rectangular form for now, we'll just use the form it's in. So now we got X of L1 equal to 6K ohms, and that's a positive 90 degrees. But X of L2 is 8K ohms. Okay, so now we got to find what Z sub A, Z sub B, and Z sub C is. Our Z sub A was said to be X of C in parallel with X of L1. X of C times X of L1 divided by X of C plus X of L1. Well, this is just simply equal to let's do polar form here. Okay, X of C times X of L1. So 4 times 6 is 24. Well, I'll write it in polar form so we can see the whole expression. X of C is 4K ohms at an angle of negative 90 degrees. And we're going to multiply that by 6K ohms at an angle of 90 degrees. Now notice, when these get added together, the angles become 0. It becomes 24 mega ohms because the K times K is third power raised to another third power, which is 6. So anything that's 10 to the 6th power is a mega value. So X of L1. So these values added together, though, will really cancel each other. Will subtract each other. So we have more Y impedance value. We have more reactance, inductive reactance than we do capacitive reactance here. So we're actually going to subtract the 6 from the 4, get 2K ohms, and that'll be at an angle of 90 degrees. And then we can simplify the math here. That's 24 mega ohms squared at an angle of 0 degrees, and we're dividing it by the 2K ohms at an angle of 90 degrees. This becomes 12K ohms at an angle of negative 90 degrees because we're subtracting 90 from 0. 0 minus 90 is negative 90. So that gives us our Z of A, but Z sub B is R2 in parallel with R3. Now remember what I said about two values that are in the same value and they're in parallel, they'll be half. So the 6,800 ohms can actually be reduced to 3,400 ohms, and I'll show that. C sub B is equal to 3,400 ohms at an angle of 0 degrees. So C sub B is equal to R2 parallel with R3, which is R2 times R3 divided by R2 plus R3. So